In this video, we are going to explore how to find a particular algebraic formula for a given sequence. So in the previous video, you will have seen something like this. Un equals 2n plus 5, for example. And this is an example of an algebraic formula, and we generated numbers from this. We imagine n is 1, and we would work out that the first term, therefore, is 7. And if n is 2, we would do 2 times 2 plus 5, which is 9. N is 3 is going to give us 11. N is 4 gives us 13, and so on and so on and so on. So we can see how we can use this to generate this list. But I want us to spot some patterns because there's other things going on. So for example, you can see that in this particular example, we plus 2 each time. That amount that we add every single time is actually significant to that previous formula. It's this. If I do another example in a moment and you had a 3 there, well, the numbers would be going up in 3s each time. Now, if I just had the number 2n, or the sequence 2n, that would be 2, 4, 6, 8, and so on. So we have to think what else we're adding on to this to get this 7, 9, 11, 13, and so on. And it turns out that this number, the number on the end, and this number here, well, if I was to add them up, I always get that first number. So we're going to use those two facts together to help us to work out backwards now what the algebraic formula is if I know what the list is. So let's take this as a nice example here. So we have a list and it is 7, 13, 19, 25, 31. So step number 1 is to work out how much it's going up by every single time. And in all the examples, it's always going to be going up by the same amount. So this one, we're adding 6. Every single time we move to the next term, we're adding 6. Okay, so now we've got some information we can use. So every formula is going to look like this. Un equals some number multiplied by n, and then we're going to have either a plus or a minus some number on the end. And we've just worked out that it goes up in 6s, so we're going to have a 6n in our formula. Now, the next thing to remember is that the 6, which we've just found, and this number on the end have to add up to the first number in the list. So if I think about it, well, what number do I have to have? It's got to be a plus 1, because a 6 and a 1 are going to add up to make that 7. So our final answer is un equals 6n plus 1. That is the algebraic formula that made that original sequence. Let's look at some further examples. So here, let's apply the same thing again. So first question is, what's it going up by every time? Of course, hopefully you can see this. It's going up in 5s. So I'm going to straight away write down un equals 5n. Okay, and now I have to think, well, what is it that I add to 5 to make 2? Well, I've got to do add a minus 3 on. So I write minus 3 there, and now I have my answer. This formula is generated by the algebraic expression 5n minus 3. And of course, we can check that we're right very, very easily. Imagine putting a 1 into this. 5 times 1 minus 3 is 2. Yep, that worked. What about putting a 2 into it to find the second term? 5 times 2 minus 3, well, that's a 7. Yep, this works. Let's just try one other one. What about putting a 6 into it? Because hopefully we should get 27, because the 6th term is 27. 5 times 6 is 30, minus 3, it works again, 27. This formula is definitely right, so do make sure you check if you're ever unsure. Okay, let's do another one. Now, this one's a bit different because this one's going down rather than going up. As we can see, if we think about what's happening each time we move from term to term in the sequence, we're going down 3. We're taking away 3 every time. So our formula is going to be un is equal to minus 3n. That's our starting point. But the same rules apply. What is it that I add to minus 3 to make that first number 28? Of course, it is positive 31. If I add minus 3 and a 31, it's going to make a positive 28. So there's my formula. un equals minus 3n plus 31. Okay, now just in case you wanted some more examples, let's see if we can do these quickly. Have a think about them now and see if you can work out the formulas like I'm doing. So I'm going to do these all in one go. un is equal to, now it's going down in 5s, so I'm going to write minus 5n. What is it I add to minus 5 to make 0? Plus 5. There's my answer to A. B, we are going up this time, and we're going up in 2s. un equals 2n. But what do I add to 2 to make minus 18? I'm going to have to do a minus 20 there. So there's my answer to B. In C, we are going down again, and we're going down in 3s. un equals minus 3n. Minus 3 minus another 2 is going to give us that first number, minus 5. So there's my answer for that one. In D, we can see quite clearly we are going down in 7s. So un equals minus 7n. I've got to think to myself, what is it I add to minus 7 though to get positive 8? And of course, it is going to have to be a 15. So there's my answer for D. And then for E, we're going to have un is equal to, and again, this time we're going up in 4s from minus 7 to minus 3. So it's a positive 4n. And what is it that I add to 4 to make minus 7? I've got to add a minus 11. And so there's my answer for E. Okay, I hope that helps you to find a formula for a linear sequence.